this is for section 1.3. So this is going to be a new page in your interactive notebook. And 1.3 is called Measuring and Constructing Angles. This part we already did in class. So I'm just going to go over what we talked about for the students that were absent. So this video might be a little quicker than if I was recording it when we actually did it in class. So what we learned about were angles. And an angle is a figure that's formed by two rays or sides with a common endpoint, which is called the vertex. So if we look at this angle as an example, our vertex is B. That's the endpoint that's connecting these two rays. The rays are the sides, and those are called BA and BC. Notice that we do make sure we use the correct ray terminology there. We can call this angle four different names. We can either call this angle B, which is just the vertex. We can call it ABC or CBA. Notice in both of those, the vertex B is in the center. And if you're ever having trouble naming them with the 3 points, a good thing to remember is that when you're drawing the angle, you should name it without picking up your writing utensil. So you would start at A and then go to B and then go to C, or you could start at C, go to B, and go to A. That's why you couldn't just skip from like C to A to B, because you would have to pick your pencil up to go to that point. And then the last name, because we have the 1 on the inside, you could also call that angle 1. When you're classifying, you're going to classify as either acute, obtuse, straight, or right. Now, an acute angle is something that most of you are already familiar with. It's going to be an angle that measures greater than 0 degrees or less than 90. And then so we have an example of that. An obtuse angle, that is an angle that measures greater than 90 and less than 180. A straight angle and a right angle are special because they have exact measures. So the straight angle is exactly 180 degrees. A right angle is exactly 90 degrees. Now the straight angle is special because it also is going to look like a straight line. The right angle is special because it's something that's really commonly found around us, and we have to also make sure that if it's a right angle, we have this special symbol. So it's a small box. If you have this small box, that means that this is a right angle. If we don't have it, we have to be careful. So if you have an angle that looks like a right angle, but it doesn't have that little box, you can't just assume that it's a right angle. You do have to have that proper notation. So knowing the different types of angles, so we can look at this one, see that it's less than 90, because 90 degrees would be straight here. And because it's less than 90, we would call that acute. The next thing that we did is we wrote down all of the angle names for each angle in this diagram. So you should be thinking about how many angles are in this diagram. So at first glance, it looks like there just might be 2. This one here and this one labeled 2, but there is a third angle, that bigger angle. So if we're just looking at angle 1, we could call it angle 1, angle QTR, or RTQ. If we're looking at angle 2, we could call it angle 2, RTS, or STR. And then the last angle, we could call angle T. We don't want to call one of these angle T because then that's unclear. Angle T is going to be that whole angle, which we can also call QTS or STQ. Another type of angle we will encounter are congruent angles, and those are angles that have the same measure. So congruent, that's our symbol. For angles, you'll see me use this a lot. It's just an angle with the line through it, and then if it's plural, I'll say angles, like apostrophe S. Okay, so those are angles that have the same measure, or sometimes I'll just do that, angles that have the same measure. And then to pick out what is congruent in a diagram, you'll see what are called arc marks. So if you have 2 angles that look the same, you can't just assume that they are the same. So if I were to draw 2 angles, even though they look similar, the only way I know they're congruent is if they have the same number of arcs. So these each have 1, so I know they're congruent. And then in this example here, I was showing that in a diagram, you might have more than one pair of congruent angles, and in that case, you might have 2 arcs, okay, or 3 arcs. So it just depends how many pictures in that diagram have congruent angles. Now, if we look at the top here, we have this diagram and some fill in the blanks. So the first one, it says blank is in the interior of what? So when we look at the interior, we're looking at the inside of the angle, and this point U is in the interior of the angle WXZ. For angle 3, you need to give another name for that. You could either say another name for angle 3 is WXZ or ZXW. And in that fashion, you could also, if you said this was angle 3 or ZXW, those would be interchangeable. For angle 4, it could be ZXY or YXZ. And then the next thing we talked about are degrees. So that's a unit of measurement for angles. That's what you guys are used to measuring angles in. The other unit of measurement is called a radian, which you will definitely look at next year in Algebra 2. When you're thinking of degrees, remember that in a circle there's 360. So if one circle has 360 degrees, 1 degree is 1/360th of that circle. So visually, try to imagine cutting a circle into 360 pieces, and then just one of those small slivers represents 1 degree. And then lastly, let's just make sure we understand when we use words like interior, like we did up here, that we understand what that means. So interior, just like if you were an interior designer, you would think about designing the inside of a house. Well, interior is going to be all of the points between the sides of an angle, or you can think of the inside of an angle. Whereas for exterior, that's going to be the set of all points outside of the angle. All right, so then what we're going to do now that we've done that foldable is we are going to flip it over, and you'll see there's a dashed line here on the back. We're just going to fold at that dashed line. So we're going to fold it. So then what we have here are our examples. Right? And then the examples we are going to do as our warm-up tomorrow. So now you can glue this in your interactive notebook. So on this blank page here, you are going to put your glue. So keep it folded. You're just putting the glue on that blank page. And then you are going to stick it on your page where we put the 1.3 measuring and constructing angles. Okay, because we're doing this for bell work tomorrow, in case you are absent, I am going to go over what these are so that you can check them. So you're naming the angle. There are 2 different names for this angle, XYZ or ZYX. Because it's a straight angle, it's equal to 180. For 2, this is going to be an acute angle. It's less than 90, so the symbol, when it says to tell whether the measure is less than 90, greater than 90, equal to 90, or equal to 180, this is less than 90. Okay, and then so it's acute. For number 3, you could call this either angle T, angle CTL, or LTC. That is equal to 90, and we can tell because you have the right angle box. Okay, so if you have the right angle box, that's how you know it's equal to 90. So we're not just going off of looks alone. For number 4, you could call this angle U, angle sun, S-U-N, or N-U-S. This is greater than 90, which would be this symbol here. And then because it's greater than 90, it will be an obtuse angle. Okay, and then it just might be helpful here to remind that this means less than 90, because see how it's eating the 90? That means the 90 is bigger than whatever you're comparing it to, and this one would be greater than, so it's bigger than 90 degrees. Okay, and then in your next page is where you are going to put your protractor postulate. And your protractor postulate, how to fill that out, is going to be in the next video labeled Part 2.